Welcome back, and today we're going to be solving linear equations, systems of linear equations by using the graphing method. Okay, so what we need to do in order to solve these is we have two equations listed on the right hand side here. I'm going to rewrite them. We have y equals 2x minus 1, and we also have y equals negative x plus 5. So as indicated in the last lesson when we were focusing on identifying the slope and the y-intercept, that's of vital importance here. That's why we went over it. And now that we've had a few weeks of practicing graphing equations on their own, now we're basically going to be taking these and we're going to be graphing two equations on one graph paper here. So let's begin by starting with some basic steps, which is to first identify your slope and your y-intercept. I know by now you're probably sick of hearing m equals and b equals. Remember that m indicates the slope, which is the rise over run. Okay, remember I told you it would be a good idea to always write down y equals mx plus b formula right below, so that way you know everything lines up and you can easily identify your m and your b on both sides. Okay, so here the m is located in front of the x. It's always 2 in this case. And b is going to be after the x. In this case, it's negative 1. But remember, I told you guys, and I stress this, it's very important that your slope needs to be written as a fraction, or 2 over 1. And your b, or your y-intercept, needs to be written as a point. In this case, 0, negative 1. Remember, the x is always 0 in the y-intercept. Looking at the other equation, we can always fill in a coefficient here of 1 if there is no coefficient. Okay, and that's important here because otherwise we wouldn't be able to identify the slope. Here the slope is negative 1 and the y-intercept, or the b, is 5. Again, remember that our slope needs to be rewritten as a fraction. So in order to change a whole number into a fraction, we always can rewrite any whole number over 1. And the y-intercept needs to always be rewritten as a coordinate or a point. So now we're going to take our information over here and we're going to graph it. So remember I told you that nifty trick in a couple videos ago about b standing for beginning point. So we're going to take a look at the first equation, y equals 2x minus 1, and we're going to begin with the y-intercept, or the beginning point. We're going to graph 0, negative 1. We start at the origin, and 0, negative 1 is down 1. Now we do our rise and our run. In this case, it was positive 2 over positive 1, so we're going to rise 2 and run 1. And I know this is a review because we spent a lot of time graphing points and graphing equations, but this is going to be, we're going to be taking this to the next step in a second. Again, you repeat the process. Rise 2, don't put a dot yet because you still have to run 1. Rise 2 and run 1. I know as a rule of thumb your math teachers have told you that you should be doing at least 4 or 5 points or so. So I'm going to go ahead and do 4 points. And it's important to have a ruler and that you can connect your dots. Okay, we must put endpoints or arrows on our line to indicate that this line is continuous and it keeps going, and we should also label all of our lines. So we just graphed the first equation, which you guys have had a lot of practice doing, but now we're going to actually graph another equation on the same graph. And if we take a look here, we have the beginning point of 5. So again, we start at the origin, and we have to find 0, 5, which is all the way up here. 2, 3, 4, 5. And then we need to do our rise over run. In this case, we're going to go down 1 because it's negative, and then right 1 because it's positive. So down 1, don't put a dot yet because you still have to run. Down 1, right 1. Down 1, right 1. And you should notice we actually just colored in the same point from the last line. Down 1, over 1, down 1, over 1. And you should do at least 4 or 5 points. And again, you want to connect your dots so we could find the point of intersection. So we put arrows, we rewrite the equation on our line or next to it. So again, the goal here is to try to find something called the POI, which your teachers have already introduced you to that, and that stands for the point of intersection. where our two lines are intersecting, the point on the graph at which point they're intersecting. In this case, if we write the coordinates, it would be 1, 2, and then 1, 2, 3. So it would be 2, 3. So our POI here is 2, 3. Okay, so I'm actually going to be combining this video with the next week's video because it's important for you to be able to see multiple representations of how you can solve something like this in another strategy, using another strategy. So I'm going to flip this over. So I'm actually going to be using something called the substitution method. The substitution method. Okay, so we actually have 3 methods to solving a system. We just went over the first one, which was graphing on the right-hand side. We also have the substitution method, and the next method is going to be called the elimination method, which I'm going to break up into 2 separate videos because that's a little bit more complicated and it involves more mathematics, which can't be squished into this video. So substitution method. Basically, we're going to use the same example. And I'm going to show you that you get to choose. This is one of those one of those times in math that's cool because you get to actually choose the method that you want to use in order to solve the question based on your preference. So if you're not a big grapher, then you can use this next method, which is substitution method. Okay, so what you're going to be doing next is you rewrite the 2 equations, and we are going to be taking one equation and simply substituting it in for the other equation. So here we see y equals 2x minus 1. We box in what y equals, and we are going to sub it into the other equation where we see the letter or the variable y. So essentially, I am setting these equations equal to each other. Okay? So now that I did that, we need to look at that. We have a multi-step equation, which we spent almost the first half of the year on. So we have to solve for x now. We begin by always moving the smaller variable to the other side. We accomplish this by always performing the opposite or the inverse. So we add 1x to both sides. The 1x's here cancel, and then we add up the other x's, and we have 3x. And as I say in class, let the chips fall. Let everything else come down. So now I simply need to isolate the variable or the x, and I do that by performing the inverse. What I do to one side, I do to the other. And now I end up with 3x is equal to 6. And then I need to, again, isolate the variable, meaning get x by itself, and I do that by performing the inverse. And I divide both sides by 3, leaving me with x equals 2. Now remember, I'm looking for the POI, or the point of intersection, which requires an actual point, an x and a y coordinate. I just found the x. So a lot of students make the mistake of doing all this great work and then they stop. Okay, what you still need to do is you still need to find the y coordinate. So we need to take our x equals 2 answer and we need to sub it back into one of the original equations. I like to use the one that looks the easiest. In this case, I don't like dealing with negatives, so I'm not going to choose the second one. The first one looks great, looks easy, I'm going to use that. So now, I'm going to sub in x equals 2 into this equation. Wherever I see x, I'm going to sub in the number 2. And remember, from 7th grade, whenever you sub in, you use parentheses to substitute. So now I have y equals 2 times 2 minus 1. When there's a number touching parentheses, you need to multiply. Here, 2 times 2 is 4, minus 1, and that gives me 3. So now I finally completed my POI, or my point of intersection, and take a look at that. Our POIs are the exact same. Using substitution method, I arrived at the point 203. Or if I am a grapher and I prefer graphing, I still got the same answer. So as you can see, there's multiple ways to approach this, and they all work. It just depends on what your preference is and what your teacher's asking you to do. So stay tuned in the next week or two for the next video on the third and final way of solving these, which is using the elimination method. This will be broken up into 2 separate videos because of how complex it can get.